Good evening, everyone. Well, tonight we're going to take a look at domain and range, and then we're going to take a look at function notation. We've already looked at domain and range, so this is going to be rather a quick overview, and then we'll get into how we write function notation and what it actually means. So yesterday we talked about domain, the set of all inputs for a function, and range, the set of all outputs for the function. Now there are a lot of different names for domain. Sometimes it's just called the x value, and the range is the y value, and you'll see that in a set of ordered pairs like x comma y. Sometimes you'll refer to the domain as the input, the value that you plug into the equation, and the output, the range, is the value that comes out. Sometimes we'll talk about being independent. You get to choose what value of x gets put into the equation, but the equation depends upon whatever value you put in, so its value is dependent. The set of the first coordinates or the set of the second coordinates, that gain relates back to the x and the y. So that's a quick overview of domain and range. Let's take a look at how we can see that in two different formats. In the first one, we have something called a finite set. This means that when x is 3, y is -1, x is 1, y is 0, x is -1, y is 1, and x is -4, y is 4. And those are finite sets because there is no value that we can choose for x to get a y output here. No value of x to get a y output. No value of x to get a y output. You can choose -4 and get 4. You can choose -1 and get 1. You can choose 1 and get 0, or you can choose 3 and -1. But those are the only 4 ordered pairs which you're allowed to choose from. In contrast, we have continuous or infinite sets. This means that you can choose 2 and get 3. You can choose 1 and get 0, or you can choose any value in between. There is multiple x values which relate to multiple y values, and so we call this a continuous or an infinite set. And we'll talk more in the future about where this comes into play, but most probably the easiest one is time continues forever, whereas if we're dealing with individual things like, oh, I don't know, number of people on a school bus, we can't have half a school bus. So there's lots of examples out there that we can go over. But that's basically what I want to start off with tonight, is a finite set and an infinite set. So here we have a function machine, and the function machine says, here's my x, here's my y. When I choose an x, what value of y will I receive? And these are the directions that are given. So in this particular case, they want me to square the x, they want me to add 2 times the value of x, and then they want me to add 3. So in this case, we are told that they want us to choose x equals 5, or -5, sorry. So we have -5, and what are we supposed to do with it first? We're supposed to square it. And then we're supposed to take 2 times my value of x, and then finally we're supposed to add 3. So -5 squared is 25. 2 times -5 is -10, plus 3. Add this all together, and we get 18. So what this means is that when x is -5, y is always 18. We could plug the same value in here. See, -10. -10 squared is 100. 2 times -10 is -20. Add 3, and we get 83. So when x is -10, y is 83. And so by putting in a value for x, we're able to generate a value for y. And that's all a function is. It's a set of instructions on what to do with the value of each x in order to determine the value of y. So function notation tells me how I write this. See, most times up until this point you've seen things like y equals 3x plus 2. You most probably knew that you could plug any value in for x and it would then tell you the value for y. But function notation is just another fancy way of writing it. This is read f of x. So f of x equals 3x plus 2. No different really than y equals 3 of x plus 2, but because it's in function notation, we're just saying the value of the function is generated by using this equation right here. We use f of x, but we could also have written g of x or h of x. And in fact, if we have multiple equations, we might just want to use a different letter to differentiate the different equations. The x in here just tells us that this is directions for x. Whatever you want to do to x, these are the directions for it. In other words, multiply by 3, add 2, multiply by 2, add 2, or square it and then multiply it by 2. X is the input variable and f of x is the output variable. So you might even say that instead of x comma y, we could say x comma f of x. Let's take a closer look. Function notation here, we have f of x equals 9 minus 4x for x equals 2. All we're saying here is f of 2. What number do they want me to plug in for x? Well, they want me to plug in 2. And then I solve. In this particular case, that equals 1. In this particular case, they wrote x equals 5. They could have written f of 5. What are they asking me to do? Well, they want me to plug in 5 for x and solve. They could just as easily say f of negative 3. What do they want me to plug in for x? They want me to plug in negative 3. F of 0.5. Plug in 0.5. And we can solve those out to find what the ordered pair is. Okay? But each time, that's the x value. The x value and the x value, excuse me, that shouldn't be there. Okay? And so as we solve through this, what's this, negative 11 and 21. So, okay, and this one we can do on our own later on. But as we look at this, all we're saying is that the value that we have given here is going to be the value that we replace x with. It's important to recognize that f of x does not mean f multiplied by x. F of x is, this is what we do to x, whatever the equation is. If it's f of 2, they're now telling me what value to replace. Notice you could also change f of x into y, so that if I'm given an equation, I have my domain, my value for x's. That will tell me all the associated range values. So if they say the domain is 1, 3, and 5, well, the range can be calculated by plugging 1 into the equation, 3 into the equation, and 5 into the equation. Given the function 9 minus 4x, what value of x results in f of x equals 1? Well, you can see here they're not asking me to plug in 1 for x. They're asking me what value of x would give me a value of 1. Remember, we said f of x is another way of saying y equals. So they're saying if y equals, or f of x equals 1. So now I'm going to replace the f of x with 1. equals 9 minus 4x. Negative 8 equals negative 4x, and x equals 2. So what value of x would result in a value of y being 1? Well, the value would be x. This one, they want me to know what value of x would give me f of x equals negative 7. Once again, they're not saying that x is negative 7, they're saying f of x equals negative 7. If they wanted me to know what x was, they would have replaced the x value here. But they didn't. They said f of x equals negative 7. They're saying after you plug in a number, you will get an output of negative 7. And now they're asking us to work backwards. Same thing applies here. And so in this particular case, x equals 4. And we could plug 4 back into the original equation to verify. What value results in x equals 8? You should be able to solve that. So what I want you to do now is I want you to come up with the value of x for this particular equation. You can pause if you need to, and you'll need this in a second. I want you to evaluate each function using negative 5 into this equation, into this equation, and into this equation. And then finally, I would like you to determine the value of f of negative 3 using this function. So I've given you 1, 2, 3, 4, and this original one back here, 5, and I'm actually going to give you some questions on the Google Doc to solve these. You'll have a worksheet tomorrow in class to help you work through these, and we'll have plenty of time on Monday to clarify any major points, but I hope that this gets you up and running. Good night.